Hello, hello, hello. Welcome back. We are going to take a look at solutions to the problems assigned out of section 8.3. So we have a solve the triangle problem, which, as always, just means find all the missing sides and all of the missing angles. What makes this a little bit different is that rather than knowing two angles and some combination of sides, what we know is two sides and an angle in between them. Okay, so we have a side angle side. The side 6, the angle 50 degrees, and the side 8 are all consecutive. So we have side, angle, side. That is a congruence. SAS is a dead giveaway that we want to use the law of cosines. So the law of cosines comes in three forms. They're all pretty equivalent. If you look them up, you'll get this, or this, or this. And you can use any of them. The issue is what you want to do is use the version that uses as much information as possible and therefore has as few unknowns as possible. So looking at our given information, the only angle we know is across from side B. So the only angle we know is capital B. Every single version of the law of cosines has little a, little b, and little c in it. Little a, little b, little c. Little a, little b, little c, little b, little c, little a. So there's no difference information-wise in terms of the sides. The only way to use information to greater efficiency is to pick the angle that we know. And since we know the angle b, we're going to use this middle version because it's the only form that uses that angle b. So little a is across from angle a, that's 6. Little c is across from angle c, that's 8, minus 2 times 6 times 8 times the cosine of angle b, that's across from side b, which is the only angle we know, and it's 50 degrees. And that's all going to equal b squared. So observe that on the left, we don't actually have any unknowns. Okay, so we have 36 plus 64 minus 96 times the cosine of 50 degrees equals b squared, or 100 minus 96 times the cosine of 50 degrees equals b squared. So b is plus or minus the square root of this, but since it is a side length, it needs to be the positive square root. And I'm actually going to get a decimal approximation of this just because we have to do further computation with it later. So it's going to be nice to have it floating around. And I get a 6.19, rounding it off to 2 decimal points. Okay, so I'm going to go ahead and label this up here. It's approximately 6.19. It's exactly this square root expression here. Now we have all three sides, and we have to start finding some angles. Now you do have two options. You can use the law of sines or the law of cosines. And even though the law of cosines has a bit more computation in it, I actually recommend you use the law of cosines to find missing angles. And here's why. If you use the law of sines, okay, to find a missing angle, you would set up something like the sine of the angle A over 6 is equal to the sine of 50 degrees over B, which is 6.19. In other words, the sine of A is 6 times the sine of 50 degrees over 6.19. So A is the arcsine of this quantity, or 180 degrees minus that. Because remember, in our unit circle approach, if you have a specific value of y and you want the sine of the angle to be something, there is in fact a quadrant 1 and a quadrant 2 angle that will produce the same value for sine. The arcsine function only tells you the quadrant 1 solution. And then you have to ask, are they both solutions? Well, they can't be. Because I started off with side angle side, that's a congruence. There's only one triangle that this can possibly be. So which one of them is a legitimate choice takes some work to figure out. Okay, so the law of sines, while it can work here, is going to actually involve extra work. Once you know all the sides of a triangle, I suggest using the law of cosines to finish it off, because the law of cosines is going to involve taking an arc cosine. And remember, arc cosine produces an angle in quadrant 1 or 2, which exactly encompasses all possible angles in a triangle. Okay, so an arc cosine is not going to miss a possible solution. An arc sine might, and you have to be careful about that. So let's proceed using the law of cosines. Let's try to find angle A, which means I'm going to want to use the version that has the angle A in it. So we get b squared plus c squared minus 2bc times the cosine of A equals A squared. Now b we just found to be 6.19. Okay. Squaring that is 38.29. Okay, so b squared is approximately 38.29. C squared, C is the side across from angle C, that's 8. So squaring that gives me a 64. Minus 2 times 6.19 times C, which was 8, times the cosine of A is equal to A squared. Little a is the side across from angle A, which was a 6, so we get a 36 here. When I have decimals that I'm multiplying in a row with other numbers, for example, right here, I have 2 times 6.19 times 8, I like to put it in a parenthesis to remind me that this is 6.19 and not 6 times 19. When doing handwritten work, it can be really easy to lose track of a multiplication versus a decimal point. So this is my little way of remembering it. Okay, but we're going to kind of round a bunch of this stuff off. So these two added together gives me the 0.29 is just hanging off by itself, a 102.29. Then I've got to do 16 times 6.19, which is almost exactly 99. It's 99.01. Since I chose to round off to 2 decimal points, I will keep it consistent. Okay, now if I subtract the 102.29 to the other side, so 36 minus 102.29, negative 66.29, so we end up with negative 99.01 times the cosine of A is equal to, and I'm forgetting exactly what I just said, 66.29. Okay, so which means the cosine of A is negative 66.29 over negative 99.01. I'll go ahead and do that. Of course, if you're using a calculator, there's no harm in just leaving it like this and then taking the arc cosine straight away. Minus 99.01. Let's see. The result is 0.67. Okay. So this is the cosine of A. And since arc cosine is not going to have any quadrant issues that pop up, A is just going to be arc cosine of 0.67. Now, if I punch that into a calculator, arc cosine of 0.67. It says 0.84, but that's in radians mode. So if I want it in degrees, because we have a 50-degree angle, we may as well be consistent. Instead of getting a 0.83658 ... radians, I'm going to just multiply it by 180 over pi to convert it into degrees, and we get 47.93. So A is approximately 47.93 degrees. So A is 47.93 degrees. And now note that we have 2 angles. So to find the third angle, we could go through a whole bunch of law of cosines work again, but there's really no point in doing that much work. Once you know 2 angles of the triangle, gosh, just use the fact that the angles of a triangle add up to 180 degrees and get your missing angle. Okay, so specifically, the only angle that's left to find is C. C plus 50 degrees plus 47.93 degrees had better equal 180 degrees, which means C is just 180 minus 97.93, all degrees, which is 82.07 degrees. Okay, and there we have it. Mark in C to be 82.07 degrees. So we have found everything on here, and we've solved the triangle. So moving on. Well, it's another solve the triangle. Notice that now we just have sides, but no angles. But what did we say in the last problem? If you have all sides of the triangle and you're trying to start finding some missing angles, use the law of cosines. It doesn't really matter which one we pick. So let's just go ahead and say a squared plus b squared minus 2ab times the cosine of angle C is equal to side C squared. Because I know all the sides, we get 4 squared plus 2 squared minus 2 times 2 times 4 times the cosine of angle C, which we don't know, is equal to little c squared, that's 5 squared. So 16 plus 4 minus 16 cosine of c is equal to 25. 16 plus 4 is 20. Subtract that over, we get negative 16 cosine of c is equal to 5. Cosine of c is equal to negative 5 over 16. So c is the arc cosine of negative 5 over 16. If I punch that into a calculator, arc cosine of negative 5 over 16, I get 1.89. Radians, which is fine. There's no degrees given here, so I'm going to go ahead and do this problem in radians. So c is approximately 1.89 radians. All right, I found one angle. Let's find another one. So let's do this one. B squared plus c squared minus 2bc times the cosine of angle A is equal to little a squared. Now, we've found all the sides. They were given to us. So little b is across from angle B, that's 2 squared. Little c is across from angle C, that's 5 squared. Minus 2 times 5 times the cosine of the unknown angle A is little a squared, 4 squared. Great, 4 plus 25 minus 20 times the cosine of A is equal to 16. 4 plus 25 is 29. Then I can subtract 29, divide by negative 20, take an arc cosine, and punch that into a calculator and get the arc cosine of positive 13 over 20, pardon me, about 0.86. And that was angle A, so I'll cross this out and say this is about 0.86. Now we could do the law of cosines again to find the third angle, or I could just remember that the angles of a triangle add up to not 180, because we're not using degrees, we're using radians. The angles of a triangle add up to pi. So b plus 1.89 plus 0.86 must add up to pi. So the missing angle is just pi minus the two angles we already found. And I'll go ahead and do a decimal approximation of that since we already have decimal approximations of the others. Pi minus 1.89 minus 0.86 is 0.39. And there's our missing angle. Okay. It's a pretty common error. It's not even an error. It's a pretty common thing for students to forget that the angles of a triangle add up to 180 degrees or to pi radians is a nice quick trick to get the missing angle when you already know 2. And they'll do extra work and possibly start making mistakes. If you know 2 angles in the triangle, just quickly get the third using that simple geometry. All right, so this triangle's solved. Moving on. So, solved the triangle, but hey, no picture was given. Fine, no big deal. Let's make our own. Okay, if I call this angle A, then this is side length A, which I don't know. If I label this with a 2, then I'm saying it's side B, which means this angle must be B. Similarly, then this is 10 and this must be C. So again, we were given 2 sides and an angle. The angle was in between. This is a triangle congruence, side angle side. There is a unique solution. In side angle side, we're going to start by finding the missing side with the law of cosines. Okay. Since capital A is the only angle we know, we're going to use the version of the law of cosines that uses that. So b squared plus c squared minus 2bc times the cosine of capital A equals little a squared. That's the version that uses the angle capital A. Little b was 2. Little c was 10. Cosine of 50 degrees, and little a is unknown. So I'm just going to fix some of my poor writing. This was 2 times 2 times 10. So 4 plus 100 minus 40 times the cosine of 50 degrees is a squared. 104 minus 40 times the cosine of 50 degrees is a squared, which means a is the positive square root of 104 minus 40 times the cosine of 50 degrees. And we're going to go ahead and just get a decimal approximation because we have to work with this later on. It's nice to have a sort of simpler form to work with. 104 minus 40 times the cosine. Make sure that if these angles are given in degrees, that your calculator is set to degrees mode. 8.48, rounded off. We're going to need it later on, so if I just get a squared, which is just the same thing without the square root, and round that off, I get 71.86. Okay, so there's A. I'll go ahead and put that on the triangle, 8.48. Now that I have three sides, we need to find some missing angles. Well, as stated a couple times now, if you have all the sides and you need to start finding missing angles, go with the law of cosines. And since we already know angle A, let's find angle B for the sake of argument. So I want the version of the law of cosines that uses the angle B. That's going to be this one. Okay, we know little a, and in fact this is why just a moment ago I made a point to write down what is a squared approximately equal to. I knew I was going to need it later on. So little a squared is about 71.86. Little c is 10, so c squared is exactly 100, minus 2 times 8.48 times 10 times the cosine of our unknown angle, and little b squared is exactly 4. Okay, so we get 171.86 minus 2 times 8.48 times 10. $169.6. Sorry about that. 169.6 times the cosine of b is equal to 4. Let me clear up that mark. Okay. Now we just need to solve this for b. So I'm going to subtract 171.86 from both sides. To get negative 169.6 cosine of b is equal to negative 167.86. Now I just divide. Take the arc cosine. And remember, the whole point of using the law of cosines rather than the law of sines is that arc cosine can give you something in quadrants 1 or 2, which exactly encompasses what triangles can have. So arc cosine of 167.86, therefore it's not going to be ambiguous like the law of sines might be. 169.6. Is about 0.1433 radians, and I'm just going to convert that preemptively to degrees by multiplying by 180 and dividing by pi, 8.21 degrees. So I come back to my triangle. We'll go ahead and label capital B as about 8.21 degrees. The only thing missing now is to find our missing angle C, but I have two angles, which means finding the third is just a quick utilization of the fact that the angles of a triangle add up to 180. Okay, so capital C plus 50 plus 8.21 must equal 180 degrees. So I subtract the 50, I subtract the 8.21 to get C must be equal to 121.79 degrees. Yeah. Now there's a quick way that you can check your work as you finish this up, which is larger angles have to be across from larger sides and vice versa. So the largest side is 10, and that's across from the largest angle, 121.79. The next largest side is 8.48, which is across from the next largest angle of 50 degrees, and the smallest side is 2, across from the smallest angle of 8.21. Okay, so if this doesn't match up, if you have the largest side across from the smallest angle, for example, you made a mistake somewhere, go back and try to find it. Okay, larger sides always correspond to larger angles in the correct order. So since that checks out, I'm confident we didn't make any mistakes, so let's move on. Another solve the triangle. No picture was given. That's fine. I'm perfectly capable of drawing my own triangles. Thank you very much. If I just label this and I label this as 2 and 7, since little a was 2, that's definitely angle A. And since this was little b, this is definitely angle B, which means this must be 170 degrees and this must be side C. And again, we have two sides and an angle in between them. That's side, angle, side. We use the law of cosines to find the missing side. Since the one angle we know is C, we're going to use the version of the law of cosines that uses angle C. And I forgot to put the cosine in there. There we are. Hooray! Capital A, sorry, lowercase a is 2, so this is a 4. Lowercase b is 7, so that's a 49. 2 times 2 times 7 is 28. C was 170 degrees. Little c was the only thing we didn't know. Okay, and if I just punch this into a calculator, 4 plus 49 minus 28 times the cosine of 170 degrees, 80.57. Which means c is approximately equal to the square root of this. I'm actually taking the square root of the expression here, not the 80.57, just to avoid any compounding of rounding errors. So if I take the square root of that, I get 8.98. And remember, we're going to need the c squared later on, which is why I bothered to write this line down as its own thing. So now we know that side length c is about 8.98. So I'm going to go ahead and put that in there. So now we need to find a missing angle. We've got all the sides, so to find a missing angle, we're going to use the law of cosines. Doesn't really matter which one. Let's just go for this one. Okay, we're going to find the angle capital A. Lowercase b was 7, so I've got a 49. Lowercase c squared was approximately 80.57. We kept that over here on the left. Minus 2 times b times c times the cosine of the unknown angle A, and little a squared is exactly 4. Okay. So we end up with 129.57 minus 14 times 8.98, 125.72. Cosine of A equals 4. Okay, so I subtract 129.57, negative 125.57. Sorry, that's not quite true. Negative 120, oh yeah, sorry, 0.57. I don't know why I spaced out there. And then I divide by 125.72, negative, of course. Cosine A is 125. The negatives cancel out. I'm just taking care of that. So A is the arc cosine of 125.57 over 125.72. And I'm going to go ahead and punch that into my calculator here. Arc cosine of 125.57 over 125.72. And I get something quite small, 0.04885 radians. Since one of our angles is already in degrees, I'm going to change that to degrees by multiplying by 180 and dividing by pi. And it is 2.80 degrees. Tiny, tiny angle. That's okay. And that was capital A. So this was approximately 2.80 degrees. So I'm going to go ahead and put that in there. And now we just have one more angle to find, but don't overthink it. If you know two angles, you can find the last missing angle by doing the fact that all three must add up to 180 degrees. So in the bottom left here, capital B plus 170 degrees plus 2.80 degrees must equal 180 degrees. Therefore, B is equal to 7.2020 degrees. Go ahead and stick that in there. And we can double check again that small angle goes with small side and vice versa. So the smallest angle is definitely our 2 degrees. That goes across from a 2. The 7.2 degrees goes across from 7, and 170 degrees is the largest angle, and it goes across from 8.98. Okay. Moving on. All right, another solve the triangle without a triangle given. That's fine. I'm getting quite good at drawing these triangles. 14, 16, 19, doesn't really matter what you put where as long as you're consistent about your angles. So across from 14, I'm going to put capital A, across from 16, capital B, and across from 19, capital C. And again, we've got sides, all of them, and we're looking for angles, so use the law of cosines. It doesn't really matter which one you do first, so I'm just going to do this one. A squared plus B squared minus 2AB times the cosine of capital C is equal to little c squared. So 14 squared plus 16 squared minus 2 times 14 times 16 times the cosine of the unknown c is equal to 19 squared. Okay, so 14 squared is 196. 16 squared is 256. So 196 plus 256. 2 times 14 times 16 is 448. And 19 squared is 361. 196 plus 256 is, let's see, a 2, carry that, get a 5, carry that and get a 4. Minus 448 cosine of c equals 361. Subtract the 452 from both sides. 361 minus 452. It's getting late in the day, so I'm just going to go ahead and use a calculator. Negative 91. Which means the cosine of c is 91 over 448, and c is the arc cosine of 91 over 448. Let's pretend I don't feel like doing any decimal approximations. That's fine, okay? This angle is, in radians, the arc cosine of 91 over 448. 448. That's fine. That's a nice exact answer. If you're not required to do decimal approximation, then there's no reason to, do too much work. Let's find one more angle. So let's do, for example, b squared plus c squared minus 2bc times the cosine of capital A equals little a squared. All right, now b squared is 256. We already figured that out. C squared is 361. 2 times b times c, that's going to be 2 times 16 times 19. 2 times 16 times 19 is 608. Capital A I don't know, and little a squared we've already done is 196. Okay, so I start subtracting stuff. So if I do 196 minus 256 and minus 361, we get a minus 421 on that side. So negative 608 cosine A is negative 421. So I divide by 608. Negative 608 to get the cosine of A is 421 over 608. So capital A is the arc cosine of that. And again, if I don't need a decimal approximation, no need. So this angle, capital A, is exactly the arc cosine of 421 over 608. Now, how am I going to find the last angle? As always, if you know two angles, don't stress. The sum of all three angles is, well, I'm working in radians this time. By default, remember, arc trig functions spit out results in radians, which means I'm working in radians, so the angles of a triangle add up to pi. So I would just say b plus the arc cosine of 91 over 448, that's my angle capital C, plus the arc cosine of 421 over 608, that's my angle capital A, must be pi. So what is b exactly? It's pi minus the arc cosine of 91 over 448 minus the arc cos of 421 over 608. And if you don't need to round off, there is a nice exact answer. Okay? If you need to make a 2 decimal approximation to plug into MyLab or something, fine. Okay, but here is the exact answer. We found all the angles. So moving on. Okay, cruise ship going in the ocean. Looks like there's a storm. All right. Maintains a speed of 18 nautical miles per hour, sailing from San Juan to Barbados, which is 600 nautical miles away, but they're not taking a direct route. Okay? In order to avoid a storm, they go off direction 36 degrees. So while they wanted to do this nice straight path here, they had to go 36 degrees off course to avoid a storm. They do this for 7 hours. Okay, so 7 hours later, here they are. And now they want to turn to head towards Barbados, which means they need to know what is this angle here. Okay, so I'm going to draw the triangle a bit bigger. Okay, so we've got Barbados, we've got San Juan, here's our boat. I know this is a 600 nautical mile difference, and I know this was exactly 36 degrees. But with only one side and one angle, it doesn't look like we have enough to work with here. But remember, the boat was going 18 nautical miles per hour, and it did it for 7 hours. So this distance is 7 hours times 18 nautical miles, knots, per hour. Hours cancel. 7 times 18 is 126. So it has gone 126 knots. So this distance is 126. And now look what we have. We have a side, an angle, and a side, which means we can solve for everything. The only thing I'm really interested, though, is this angle here. That's how far I'm supposed to turn. But observe that that missing angle is just 180 degrees minus this one. So if I can find that angle right there, I'm basically done. So with side angle side, unfortunately, there's really nothing to do other than use the law of cosines to find the missing side and then find missing angles from there. So even though we don't necessarily need this distance, we're going to find it. Okay. And we do actually need it for part B anyway, so there's no harm. Okay, so looking at the way I've set up this triangle, we are going to have 600 squared plus 126 squared minus 2 times 600 times 126 times the cosine of 36 degrees is equal to our missing length squared. Okay, those are some big numbers, so bust out the calculator. 600 squared plus 126 squared minus 2 times 600 times 126 times the cosine of 36 degrees is 253,552.63. Now, we have so many digits floating around that I feel comfortable rounding these things off to the nearest integer. So 253553. Which means d is approximately equal to the square root of all of this. And again, because of the size of everything involved, I'm just going to round it off to the nearest integer. If some assignment says 2 decimal points, well then keep 2 decimal points. So d is approximately 504. Okay. So now that I know this side length d is approximately 504, I can find this missing angle down here, which I'll call, let's just call it x. And we're going to do it with the law of cosines. Okay, we're going to find our missing angle with the law of cosines. Remember, the law of sines is always going to be a little ambiguous about, am I in quadrant 1 or quadrant 2? The law of arcsine function only ever tells me quadrant 1. So to find angles, when you can, use the law of cosines. Okay, so trying to set up that angle there is going to use the sides on both sides of that angle. So I'm going to have 126 squared plus 504 squared minus 2 times 126 times 504 times the cosine of the missing angle is equal to the opposite side squared. Now observe, I can square 504, but remember that that would just be squaring d, and d squared I already had an approximation of 253,553, which isn't quite 504 squared. But this is avoiding compounding of rounding errors. I had a bit of rounding error when I took the square root, and if I square that, the error is just going to compound on itself. So I'm just going to go back to this expression for d squared. So this shouldn't really be 504 squared, it's just d squared. which is 253,553. So if we do 126 squared plus 253,553, we get 269,429. So 269429. 269429 minus 2 times 126 times 504 times the cosine of theta. So that's 2 times 126 times 504 is 127008. Cosine of x, 600 squared, we don't need a calculator. 6 squared is 36, and then I square the 2 zeros and I get 4 zeros. Okay, so let's take 360,000 and subtract 269,429. So we end up with negative 127008 cos x equals 90571. Dividing by the negative 127,008, we get the cosine of x is negative 90,571 over 127008. Okay, I'm just going to clear up some space by erasing the stuff at the bottom. And therefore, the missing angle is the arc cosine of this quantity. Punching that into a calculator, arc cosine of minus 90571 over 127008. The calculator tells me 2.36 in radians. Remember, arc cosine by default is in radians, and most people navigating boats do not want to be told how far to turn based on radians. They want degrees, so I'm going to multiply this by 180 and divide by pi, and get 135 degrees. Okay. Rounding off to the nearest integer, this is about 135 degrees. But that was not how I need to turn. Okay, remember, this angle that we just found was here. It was x. This theta is how I need to turn the boat. So if this angle, I'm up in the diagram now, this angle is about 135, how far do I need to turn? Well, theta is just 180 degrees minus x. So that's 180 degrees minus 35 degrees, which is 45 degrees. So tell the person to turn 45 degrees left, and now they should be pointed directly at Barbados. So that is the angle through which the captain should turn to head directly to Barbados, 45 degrees left. Or sorry, you're on a boat, 45 degrees to port. Okay, part B. Once the turn is made, how long will it be before the ship reaches Barbados if the same 18 knot speed is maintained? Well, I know how fast I'm going, so all I need to know is how far I need to travel. But we already found that. Okay, the distance we need to travel is about 504 knots. Okay, we already found that in the previous problem. Even though that distance wasn't immediately relevant to the answer, it is called for now. Okay, so since we need to travel from where we are to Barbados, this distance was exactly 504. Okay, so the distance to travel is 504 knots, and we're going 18 knots per hour. The time required is just 504 divided by 18 hours. And 504 divided by 18 is 28 exactly. Hooray. Yeah. So it's a 28-hour journey from this point forward. One bit of flavor I like to put on problems like this, even though it isn't exactly asked for, is how much time did we lose? Okay, we had to sail around the storm. This made the journey take longer than it otherwise would have. Okay, so I'm going to ask a supplementary question at this point. How much extra time are we adding to our journey by going around the storm? Okay, so our journey, we went 7 hours, then we turn, and we go 28 hours. So we go 35 hours total. If we had gone direct, well, we'd be sailing through a storm, but ignore that. We would have had to go 600 knots at 18 knots per hour. Okay, so the time would be 600, not 1600, sorry, 600 divided by 18 hours. And if I compute that, we get 33 1/3. Okay, so how much time did we lose by sailing around the storm? Instead of taking 33 1/3 hours, it took us 35 hours. The extra time is just the difference between them. And that's just 1 2/3 hours, or 100 minutes, an hour and 40 minutes. So over the scope of a day and a half, roughly, of a journey, we only lost about an hour and 40 minutes by going around the storm. It's not that big of a deal. Okay. So that wasn't actually asked for in this problem, but it is a nice little extra step I sometimes like to ask on these questions.